Hello everyone, thank you for joining us today. On behalf of Saint-Gobain Technical Installation, welcome to our webinar, Decarbonizing Industry with Insulation. Let me introduce myself. I'm Hendrikje, the Marketing and Communication Manager of the Business Unit Technical Installation. I'll be introducing this webinar and our speakers in a few moments. But before we start, I would like to say a few words about Saint-Gobain Technical Installation. So we can talk about the different markets in which we operate. Since 1937, we've been providing sustainable insulation solutions to customers in all technical insulation markets, such as industry, marine and offshore HVAC, and OEM, like automotive or household appliances. Next, please. We are present worldwide through our two international brands, ISOVER and Kaiman, as well as a certain number of local brands. Our strength is that we are not only global, but we are also local, because we have dedicated teams in a certain number of countries. We have dedicated production sites in many regions. So all this allows us to be close to our customers. Next, please. We are experts in an array of insulation materials. The ISOVER brand stands for mineral wool solutions out of glass wool or stone wool that are mainly used for applications above ambient temperature that can even go up to very high temperature applications up to 700 degrees. And the Kaiman brand stands for elastomeric foam solutions, which are dedicated mainly for cold applications below the ambient temperature where there is a risk of condensation. Next, please. Today's topic, decarbonizing industry with insulation. We will hear during the next 45 minutes how insulation can have a positive impact on energy consumption, on CO2 emissions in the industrial sector. A few practical details, if we can, thank you. A few practical details, just you can raise, of course, your questions during the webinar. During the webinar, at the end of the webinar, whenever you want, you have a questions and answers button in the chat on the right-hand side of your screen. So don't hesitate to raise as many questions as you would like to. We'll take some time at the end of the webinar to answer all them. And now I'm going to introduce the two speakers, our two experts, Alberto Garcia Blanco and Juan José Orta. Alberto is our International Specification Manager in the Business Unit Technical Installation. He is very experienced, 23 years in the Saint-Gobain group already, and 9 years in his current position, so a real expert of industrial insulation. He's accompanied today by Juan José Orta Martínez, who is the Specification Manager for Industry and OEM in ISOVER Spain. And Juanjo is originally an acoustic engineer. He's also very experienced with 17 years in the group and 8 years in his current position. And what's also worth mentioning is that Juanjo is one of the most experienced tip check engineers in our teams. And this brings us directly into our topic today. So guys, Alberto, the floor is yours.
So thank you very much, Hendrikje, for your introduction. So let me explain to you very quickly what is the agenda for today. So we will go through a path of 5 different blocks in this webinar. So first we will try to understand through the figures what is the position of the insulation, what is the role of the insulation, that is the block 2. Later on we will have a look to the current state of the art and future possible state of the art of the insulation inside of the industrial world. And finally, we will show you some real examples in how we are doing inside of the Saint-Gobain group, and some tip check that you will see what a tip check is inside of this presentation that we are performing actually, and which are the results just behind. So let's start with having a look to why or how we can decarbonize industry through insulation. And I think that the best way is just looking at some figures as a first step. So here we can see that the greenhouse emissions in Europe by sector, and here you can see that really on the left-hand side, you can see that these greenhouse emissions are coming from many different sectors. So agriculture, residential, blah, blah, blah. But the real important one and where we can really work in is in the industrial energy consumption. So actually, you can see here that more than 500 megatons of CO2 equivalent are coming from the energy consumption. And it's not only affecting to one single industry. In the left-hand side, you can see that all of the industries are affected by this kind of losses coming from the amount of energy that we are using in our processes. And here is where you will see that insulation can play even an important role, and even much more in dealing with today's situation. We have a lack of energy resources, let's say, in Europe actually. So with the crisis that we have with the war in Ukraine, we can see that we are suffering or struggling for having gas in our stocks, and even the same with the fuel. So actually the prices has rocketed like crazy in the last 2 years, let's say, and actually it's not only about prices, but it's about amounts of energy resources that we have in our hands. So in front of this, it's clear that we should start thinking about what to do. And here, when we have a look to the total CO2 emissions, what we can see is that where can we save or change a little bit the picture that we have today? And in the left-hand side, you can see that we can work in many different parts. So we can point out to renewables or electrification of our sources inside of the plants. We could change even to hydrogen, maybe, and we could work as well with the CO2 that is emitted, trying to block this CO2 or to store it or whatever. But really, we have still a 25% that could be, made better by reducing or having a better energy efficiency. And when we zoom in this part of energy efficiency and we look at our processes, we see that one of the losses is really produced by the heat loss. And here, when we are talking about heat losses, usually we're talking immediately about insulation. So here we have the first idea of how insulation could work inside of this, let's say, a scheme that we have for reducing energy and, of course, reducing CO2 emissions as well at the same time. They are totally in parallel, right? So let's have a look deeper, a little bit deeper, about the role of insulation in this kind of game that we have. And the first thing that could give us an impression of how our systems are working is the surface temperature that we have in our machines, in our pipes, in our flanges, in our valves, in any kind of element that usually we're having in an industrial plant. When we have a look to that, we see that the current losses over surfaces, so I mean through surface temperature, is 193 terawatt hours. So this is a huge amount of energy that we are losing about the casing of our machines or about the cladding of our pipes or all these elements that at the end they are hot. And you see that all the sectors are affected by this kind of losses. In principle, the sector that is affected the most is the electricity sector, but all of them at some point are having heat losses in their processes. And regarding, so this is absolutely linked with the amount of money that industries has to spend to, I would say, overspend in heating up machines, fluids inside pipes, and so on and so forth, just due to a certain bad scheme, let's say. This scheme could be improved. And if we have a look to the energy sources, the consumption of these energy sources, we see that the biggest issue that we have actually in industry is really linked with gas. And gas is precisely what we are lacking actually, because the gas coming from Russia in the north of Europe is not coming anymore. So situation is becoming quite critical. But in front of CO2 emissions, you see that the gas is playing an important role, and gas is emitting CO2 as well. So no matter how you look at it, is quite easy to understand that we need to attack these massive losses that we are having through the surfaces of our equipments in the plants. So how big the savings could be? Something like 10 years ago, and I will tell you a little bit more about this European Foundation, there was a study carried out in Europe just to understand how big the losses were and what was the potential in terms of savings. And what they analyzed is two different scenarios. So the current scenario that we have, and later on, two different scenarios. One scenario is just if we would design our stuff with a cost-effective look, let's say. And there's another scenario that is a little bit better, that is designing our processes and our machines with an energy-efficient approach. That is a little bit different. In some slides, I will show you a graph that probably will make it very clear. When we see and we look at the figures of the potential as energy savings, we see that the units that is expressed is in petajoules. I don't know if you all have in mind what a petajoule is, but it's the figure that you have on the screen plus 15 zeros. So it's an absolutely massive amount of energy. If you want to really, instead of quantify by figures, just to understand how big it is, it's equivalent to 15 coal-fired power plants. That is the scheme that you have here of 500 megawatts each, or it's equivalent to 10 million households, or it's the equivalent of all the energy that actually used in the Dutch industry. So this is just to illustrate how big these losses are. And in this graph that you hear on the left-hand side, you see that this is the current situation. So you see in light blue, you see all the heat that we are losing in our processes due to the lack of insulation. And this is, and the dark blue is just illustrating the energy that is lost actually through the insulated parts. But again, coming back to these two different schemes, we could reduce these losses by 66% just by designing our items following a cost-effective scheme, let's say, and we could even save up to 75% of the total losses that we have through the casings and the claddings of our pipes. So again, now it seems to start being clear that a massive savings can be done relative to the use of insulation, only to the use of insulation, right? So let's have a look to the typical, you have to build up a new machine, and you decide to make it as usual. And as usual means what you have on the left-hand side of your screen. So it means that you would invest, imagine the total cost of ownership, so the total cost that you will have to pay for this machine, and with the current investment that we are doing in industry, you would spend more or less 11% in insulation regarding the compared with the total cost of ownership. And during the life of this element, you will be paying 89% of this total cost. So the total cost of ownership is coming really from the energy that you are losing. And our proposal, when we propose to move to a cost-effective insulation, the proposal really is just to increase this 11% to up to 19%, so increase the insulation amounts, and just by that, you can reduce your total bill along the life of the element by 23%. So again, the savings are quite massive. But still, I guess that in your minds, it's quite difficult to make an idea of what is the meaning of these losses. So for that, I would like to show you one example. And let's have a look to imagine an insulated industrial valve. In this case, it's not really a very big one, so DN 150, and with an inner temperature of 150 Celsius degrees. And you see, well, in industry, 150 Celsius degrees is not so high temperature. In industrial processes, is quite normal to find processes with 300, 400, 500 degrees even. So let's imagine, with that, I mean that this temperature is not extreme. It's quite normal in an industrial process. And let's imagine that this valve is working the whole year, all the time. So the energy losses per year that we would have in this single uninsulated valve would be around 11,000, 10,600 kilowatts hour along the whole year. Is that big or not? Probably, so far you cannot understand exactly how big this figure is. But what you will understand immediately is just by insulating this valve, we could drop down dramatically the amount of energy that is lost. And our energy savings per year could be around 10,000 kilowatts hour. And so we would have reduced the losses from 10,600 down to 600 kilowatts hour. So we could reduce 95% of the total losses that we were having in this valve before having this valve insulated. Okay, and coming back to these figures, because these are figures, and when we are talking about kilowatts hour, nobody understands, or almost nobody understands how big it is. Let's illustrate it with a real example. If we would translate this 10,000 kilowatts hour that we can save just by using insulation, we could run a Tesla model for 20,000 kilometers, right? So now you have a clear image of how big is the energy that we are losing in one single valve. Now let's imagine a real industry, the typical petrochemical compound. In a petrochemical industry, I don't know if any of you had the opportunity of visiting this kind of industries, it's quite normal to have 20,000, 30,000, up to 50,000 valves and flanges in the processes of one refinery. So now multiply this 10,000 kilowatts by 15,000 elements or fittings that we could have like that in the process. Now I think that the idea is quite clear about how massive is the amount of energy that we are losing, about the thermal energy that we are losing in our industrial processes. And maybe, it's the first time that you're in front of this clear idea, and maybe at some point you feel a little bit dumb because you think, okay, I never thought about this. But believe me that you are not the only one. Here I would introduce myself a little bit. So before being in this position, as Hendrikje introduced me, I was production and maintenance manager in one of our plants, in one of our insulation plants. So, and every single year, my colleagues from the EHS department came to my office, and they asked me, Alberto, what do you have in mind for next year? I mean, how are you going to save energy and reduce the CO2 emissions? And I was always thinking about, okay, we will improve the leakages that we have in our compressor, and we will use compressor only when it's required. We will change the valves to efficient valves. We will play with variable speed drives. We will buy more efficient engines, blah, blah, blah. But I never, ever, even working in insulation, I never thought about the insulation and as a possible source of energy saving. And it's really a low-hanging fruit. It's something that is quite easy to be done. So just having this in mind, how was possible having this situation in Europe and nobody was or seemed to be doing nothing? Well, that's the reason why 10 years ago, and a little bit more than 10 years ago, what we call EAAF Association, EAAF is the acronym of European Industrial Insulation Foundation, started to develop a work on this topic. And the main aim of this European foundation, that is a non-profit foundation, is to set up to promote and establish the use of industrial insulation as a widely understood and accepted means of achieving sustainability. So completely linked with CO2 emissions and energy. And actually, you know that in Europe, we are not achieving exactly the targets that we put to ourselves. So in 2020, we failed with a 20% reduction in CO2 emissions. And why is that? The reason just behind that is the lack of regulation in industry. When we compare the situation that we have in industry with the one that we have in the building industry, we see that that is absolutely different. So in building, we have very clear regulation about the losses that we can have through the walls or through the roof of our homes or the buildings, right? And they are pretty low. If you look at the figures that we have here on the screen, they are pointing out to 10 watts per square meter. But when we go to an industrial, imagine a power plant, and we compare the temperature that we have in the processes inside of this power plant, that could be as an average around 250 Celsius degrees, compared with the 20, more or less 20 degrees that we have in our homes, you see the losses that are imposed by the building code. But in industry, we have nothing that is really compulsory. The only thing that I could find is a kind of indication in an old German standard recommending something around 150 watts per square meter. So you see 15 times more in industry than in building. And I wonder why is allowed losing so much in industries and it's not the case for buildings. for me, in principle, doesn't make sense. So we should go at least in a similar position, but not so different. And in this case, you see that in these processes, having 250 degrees inside of the pipe or the duct or whatever, we use as an average 100 millimeters as an insulation thickness. So you see that even in modern building codes, we are using even more insulation having 20 degrees than having 250 degrees. So in principle, it doesn't make sense. So having a kind or making a kind of summary about all the good things that insulation could bring to us in terms of energy efficiency and CO2 reduction. First of all, for the climate, because clearly we can reduce, and you have seen it previously in one of the slides, we could reduce up to 45 megatons of CO2 emissions. We could increase, of course, the energy efficiency, and by that supporting the circular economy somehow. For Europe, for the place where we are living, in this case, we would contribute to the Green Deal. Remember that we have, keep in mind that we have targets for 2050. We could create and save jobs in Europe. Actually, you know that quite a lot of money is dedicated to the green recovery, let's say, of Europe. So a lot of business is done there. And finally, for our processes and our industries, increasing our competitiveness compared with other industries that are not so efficient in terms of energy and CO2 emissions, and of course, creating safer and better working conditions, right? So with all this introduction in mind, let's have a look to what is the current state of the art that we can find in the different specification along the different industries. So first of all, you know, on the left-hand side, you have the current approach. So actually, well, it's true that things are slightly shifting to what you have in the right-hand side, but let's start discussing a little bit about safety. Because in principle, you know, insulation was used only for safety purposes. So it means for not getting burned. But this approach could be valid 50 years ago because the energy prices were really very low, and CO2 emissions were not really in our minds. But actually, I think that today, this approach is not possible anymore. So because the problem of this approach is that it's not taking into account the energy and the money saving potentials. So at the end, you know, with this approach, you are losing a lot of opportunities. So it's good for not getting burned. That's okay. But I think that many more things could be done. And these many more things could be explained in the right-hand side. So here you can see that insulation systems could be designed from an economical optimum point of view. What does it mean? Here in this graph, you can see that on the green line means the insulation cost per thickness, I mean per millimeter of thickness, and in green and in orange, you have the heat loss. So as soon as you increase the insulation thickness, you decrease the amount of energy that you are losing in your process. And of course, if you put both together, so the blue line would be the total cost of ownership, you see that there's an optimum point. So at some point, this total cost of ownership is as low as possible. So this is what we call economical optimum, right? So this approach is good because at the end, you are taking into account the energy and insulation prices of today. This is the pros, but it has also cons. And the cons is that, okay, it's not taking into account what could be the energy prices in the future. Imagine that you would have designed any element 3 years ago, and later on, some months afterwards, you have the crisis that we have nowadays in Russia. So it's possible that this point would have changed, would have moved very to the right? Yes, because the energy prices are changing. So it means that this way of designing is a little bit static, let's say. And it could be improved. And the other thing is that it's not taking into account the CO2 emissions. So it's only cost-based. What is actually, you know, it could be improved. So now, if we have a look to what I think that will be the future, and the future that will be coming quite soon, is a German standard that actually is official in Germany that is called the VDI 4610. And in the future, in the European Union, actually, we are working in this new standard will be called the EN 17956. There's a definition of energy classes, and these energy classes are defined, following what is called an ecological calculation. So the way of thinking is more or less the same than in the previous graph that I explained to you. But in this case, instead of comparing the cost of insulation and the cost of energy, what we are is just summing up the total emissions from operations, so when the material is really installed, and from the manufacturer. So from, for producing this insulation, we need to emit a certain amount of CO2. So when we put together the total emissions that we are creating by one insulation solution, we have again an optimum. And this optimum is what is called, ecological optimum, right? And in my opinion, this will be the future of about how to design insulation systems. And probably, even coming from the governments, from the state, even from the European Union, at some point, probably, for receiving subsidies. This is actually the case in Germany. If you want to receive a subsidy from the German state, you need to fulfill being at least Class B, following the BDI 4710 scheme. So it means that they are pushing to you, if you want to get some money from the state, but you need to fulfill at least certain requirements. So this is one step ahead, in my opinion, a very important step ahead that will change completely the way that how we are designing today insulation systems. So just to illustrate a little bit how much it will change, here, I ran a comparison between the current state of the art. So imagine a process having 180 Celsius degrees with an insulation thickness of 150 millimeters, the typical stone wool material, right? And in this case, with this insulation, you would be Class E regarding the German BDI standard. So, and the current losses, thermal losses that you would have in your process would be around 50 watts per square meter. In this case, if you would design the system following the schemes given in the BDI 4710, but as a Class B, you would reduce this amount of energy by 44%. So it would come down to 28 watts per square meter. But you should use a thickness of 230 millimeters, even having a more performant material as this is. So you see that the change in the insulation thicknesses and even in the insulation performance of the material should be increased and should be changed, right? And I think that this is what we have in front of us. And you see that making this exercise, the same exercise that I did, but with the total amount of energy that we are losing in the European Union of the 27 countries that we are today, you see that we could come from 16.7 megatons of oil equivalent to only 2.7. So again, massive savings linked with this new approach. So that's why I think that there's no escape from this new approach. For me, this is what will happen. This is what I was telling to you regarding the thickness increase. It's really a change in the current approach. So now I would like to tell you how we are walking the talk inside of the group. So all these things that I explained, what are we doing inside of a big industrial group as we are inside of Saint-Gobain? First thing that we did is just acquiring the knowledge. So that's why we went through the qualification program given in this European Foundation for Industrial Insulation. And we have now a big bunch of people around Europe, and even in other parts of the world, like Saudi, for example, Saudi Arabia. We have people that are really prepared just to study and see how the processes are if they are good or not. And this is not only to be carried out inside of our group, but as well, dealing with the problems that our customers could have regarding insulation. So first thing that we do usually is analyzing things. But as I told you, this is for customers and inside. But inside, we developed an internal program that we call it T4BEST. So here, the scope is the thermal insulation performance checks. So it's a kind of audit program. And the aim was boosting energy efficiency, increasing the safety in our processes, and improving as well the temperature control that we have. And by that, we could, and in some cases, we could reduce even the heat losses by 1/4. what is quite a lot. And when we started with this program, we had two real targets in our minds. First, improving the processes in our plants, and second, showing with our example that we lead really by example, showing to our customers our real examples and trying to develop with them exactly the same things that we did inside of our plants. So the first expertise that we had came from our own processes and plants. And this is what we are trying to do to extrapolate to our customers, right? And one thing that we realized when we started this program, and after analyzing many processes, is that design phase is absolutely key, because replacing insulation afterwards is not so easy. And that's why now we have defined a new Saint-Gobain insulation specification. So now what you have in front of your eyes is an official document inside of Saint-Gobain that is exactly the insulation specification. And as you can see, this specification now it's quite advanced, because now has been developed really following exactly the criteria given in the BDI 4710. And now we are designing our machines, our pipes, our flanges, our elements following an ecological class B. So actually, for example, in the Saint-Gobain group, in the new designs, we could receive the subsidies from the German government, for example, if we invest for acquiring exactly this ecological class B. So regarding our experience and what we do internally and externally, here in this graph, I think that is quite illustrative about the amount of experience that actually we have. So you can see that actually we have carried out almost 300 audits internally and externally. So here you see that we have audited actually 38 plants inside of the Saint-Gobain group, and we have run 276 on the customer facilities, right? So and by doing this exercise at the end, we have found out a crazy amount of CO2 emissions that could be saved, and megawatts hour that could be saved as well. As you have it here in figures, we are talking about more than 500,000 megatons hour, and in terms of CO2 savings, almost 124 megatons. What is I think that the figures themselves illustrate how big the opportunity is just behind. And how can really be achieved? What we do, the method that we follow is just studying 4 different things that you have in your staff. So first we analyze if the insulation material can be improved or not. Later on, we study what would be the perfect insulation thickness, in this case, either for achieving the economical solution or for going for the ecological solution. We study as well what is the state of the art regarding the thermal breaches, because they could represent an important amount of energy lost. And finally, we have a look as well to the cladding, to what is the outer surface of your processes. And by that, you know, this is a real example that we carry out in a steam pipe. And you see that this steam pipe was designed just for having some safety, so for having less than 60 degrees surface temperature. And just by changing the insulation, optimizing the thickness, reducing the thermal breaches, and change the cladding with one with a lower emissivity, we could at the very end reduce the total losses, you see, by almost 50%, 49% exactly. So with this, I guess that you have a very clear idea of how just by improving the insulation that you have actually in your processes, you could reduce your energy bill down to 50% of the current amount of money that you are paying. And of course, in parallel with that, you have always the CO2 emissions. So sustainability is just absolutely linked with the energy, with the use of energy, right? So now I guess that you have more or less a clear idea of what our business are about in ISOVER and in Cayman. So actually what we can help you, if you need it, is we can improve the current insulation specification that you have in place just by studying exactly how it could be improved regarding material thicknesses improving thermal basis, as I explained. We could even run audits in your facilities. We have softwares that are prepared for running not only thermal analysis, but economical analysis as well in terms of payback time, total cost of ownership, and all these kind of things. And of course, everything is laying on best-in-class technical materials. I mean, we, as Hendrikje introduced, we are the only ones who are a multi-material. We have a multi-material approach. So depending on the temperatures, we can deal with elastomeric foams coming from Cayman, to glass wool coming from ISOVER, or stone wool coming from ISOVER as well, or even ultimate, that is the last generation stone wool. So thank you very much. This was what I wanted to tell you and to introduce to you. And I will give the floor to my colleague, Juan José Orta, and he will explain to you some real cases performed in these audits. Thank you very much.
Thank you so much, Alberto. I am going to show you some real cases of thermal insulation inspections. But first of all, I want to ask what is a tip check audit or thermal insulation audit. Tip check inspection is an inspection to evaluate the thermal performance of the current insulation in existing or in future plants. We calculate the energy and money savings potential and the CO2 reduction potential. These audits demonstrate that with a better efficient insulation, the owner of the plants can save energy, can save money, and reduce CO2 emissions. This type of inspections are divided in 6 different steps. The one of them is the technical preparation. We talk with the owners of the industrial plants to agree what is the goal, what is the target of this type of inspections. We do a visit of the plant. We visit the plant to know what the type of process, what type of systems we must inspect. We execute the tip check. We analyze the state of the current insulation with thermographic cameras and other equipments. We collect all data we need to do the calculations, and with different softwares, we calculate the energy savings potentials and money savings potential and the reduction CO2 emissions. We put all these type of conclusions and calculations in a report, and we show to the customer the state of the current insulation, for example, if it is damaged or it is uninsulated, and all data about the savings potentials. We have done some audits in different plants, and we can show 2 real cases. First of them is 2 fuel storage tanks. We did this inspection in 2021 before the current crisis. The tanks have a capacity of 14,000 cubic meters with a dimension more or less 30 meters of diameter and around 20 meters high. We realized that the insulation was very damaged and the thickness insulation was insufficient. The value of key loss calculated was more or less 225 watts per square meters. We detected energy savings more or less at 2,000 megawatts per year and money savings at 224,000 euros per year, and CO2 reduction emissions potential more or less 1.5 kilotons. After we presented this report to the customer, he decided to invest and to improve the insulation of the 2 storage tanks, substituting all insulation, walls and roof, increasing the insulation thickness. And in this case, the heat loss decreased a lot, and the final values were more or less 15 watts per square meter, with a energy class C classification more or less. The customer did an investment, 272,000 euros, and he got a payback at 1.2 years for this type of investment for the 2 fuel storage tanks. If you want more information about this example, you can read this article in our web. You can You can see the leak in the down part of this slide. Other example of the thermal insulation audits or thermal insulation inspection was different reboilers in the different cracking unit in the petrochemical plant. We inspected 10 units of reboilers and auxiliary pipes, input and output pipes. The current status of this insulation is the same than the other case. The insulation was very damaged and the thickness insulation was insufficient. The data of the heat loss were more or less 540 watts per square meters, and we detected energy savings potential more or less 578 megawatts per year, money savings potential and 124,000 euros per year, and a reduction of CO2 more or less and 162 tons per year. The all insulation was improved, substituting the current insulation and with a new insulation with different thickness. The thickness of the insulation was increased more or less the double, and we detected, and after the inspection and the investment, the heat loss was less than 80 watts per square meter. The client had to do an investment to 272,000 euros and no, an investment of 93,000 investment and with a payback of more or less of eight months. You can see that with these types of heat check audits, we can demonstrate that we can save energy, we can save money, and we can reduce CO2 emissions, helping to decarbonize the industry. Thank you so much for your participation.
Okay, thank you, Juan, and thank you, Alberto, for this very inspiring presentation. I think it shed a lot of light on the untapped potential of insulation in the industry. And yeah, we know that there is still a long way in front of us, but I hope that we all understand now that insulation is a quite easy and economical lever on the roadmap towards a decarbonized industry. So we have now time for questions, and I will check if we have questions in the chat. So the first question, is it possible to influence the insulation thickness recommended that appear in codes and standards?
Well, at the end, for improving what is actually included in the standards, there are committees. So yeah, it could be done. Actually, you know, the exercise that was done with the VDI 4710 in the past in Germany, it's a good illustration of how the thicknesses could be increased. I mean, they are giving to you new rules that they are logic rules that allow you to increase the insulation thicknesses. But for accomplishing that, for being able to do that, you need to be part of one of the committees that are studying these kind of things. Usually they are engineers, technical people who are fully dedicated to insulation. But yes, it's possible. But it's really quite a long way in terms of time. I mean, it's something that is not done from today to tomorrow. Usually it takes months or even years to change one standard. So the answer for me is yes, but it's quite long in time and not easy. Yeah?
Okay, thank you, Alberto. Another question, according to you, which is the main factor having an impact on efficient thermal insulation? Is it the type of insulation material, the insulation thickness, something else?
Both, because at the end, you know that what is really creating the insulation itself is what we call thermal resistance. The thermal resistance is influenced by both, by the conductivity of the insulating material and by the thickness. So, and they are linearly operating in the formula. So it means that both of them are having exactly the same importance. What is true is that improving the conductivity in the insulation products is much more difficult to be done than increasing the thickness. So usually, you know, at some point you have a certain limitation regarding the insulation, how effective it could be, the insulation material itself, and the only way that you have for improving the insulation system is just increasing the thickness.
Very clear. Next question. Regarding the real cases, what are the typical things which have a bigger savings potential that you find during the tip check inspections?
This question is for me. We have done a lot of tip check inspections. We have realized that the 10% of the surface of any industrial plants are non-insulated or with damaged insulation. For example, flanges, valves, pumps, filters, expansion joints. Normally, they are non-insulated. Remaining the 90% of the insulating surfaces, the 75% of this 90%, the insulation could be improved and reduce the heat loss. We normally see that a lot of parts or a lot of elements in industrial plants are non-insulated.
Okay, very clear. Thank you, Juanjo. Next question. The VDI is a German standard. Why do you consider it as so important? All my projects are based out of Germany, so no sense for me talking about German standards.
Okay, I understand the point. Well, in this case, as I explained in one of the slides, this German standard will be part of the European Union standards in the coming future. Actually, you know, as explained, there's a new EN standard that is under development right now, and probably will be in place before, at the beginning of next year, in 2024. So it means that actually, if your projects are out of Germany, but you are still living in Europe, probably, you know, right now you are not affected by this VDI, but in probably in 1-2 years, you will be fully impacted by this standard. So that's why, you know, and at the end, the EN standard is just a transposition of the German standard. It's exactly a copy and paste. So it's exactly the same. So that's why I wanted to introduce this VDI standard inside of this webinar, because at the end, this VDI and German standard won't be German anymore, and it would be European in the coming future. So that's why I consider that the VDI 4710 is important to you, even if you are not living in Germany, because in the next future, it will be your rule of law as well.
Okay, so I think this also answers more or less the next question. The next question was, will the new EN standard replacing the VDI be mandatory in the EU? Sorry, and how do you think it will work? So I think you answered to that. I don't know if you
well, I could add something in front of this new question. I could add something because this EN, as I said, I think, and this is my thinking, my educated guess. It doesn't mean that it will be the reality, but I guess that at the European level, it won't be compulsory as such. So it will be, each country will have the freedom, let's say, to develop this standard as they want. And probably, you know, almost everybody will follow the same scheme as they have in Germany. So it means that, you know, if you want to receive a subsidy, you would have to fulfill a certain energy class. We don't know if it would be class B, class C, something around that. Actually, you know, the discussions that I've been present, the discussion actually is going in the direction of having at least class C for the different European members. There's a certain agreement on that. So maybe Germany was a little bit more one step ahead than the rest, but in the rest of Europe, I guess that in the future it won't be compulsory as such. But again, if you want to receive some subsidies or money from the state, probably you will have to fulfill some of the criteria as explained in this new standard.
Okay, interesting. Next question. Is there any governmental subsidy in Spain associated with the improvement of insulation?
Yes, there are some subsidies in Spain, one from the region governments and other from the national governments. And all these type of subsidy are focused in the energy savings. You can demonstrate that you can save money savings and energy savings, and with different reports or different audits, and you can send all the documentation to the region government and to get the different subsidies. That this type of subsidies can reach more or less 30 to 40% of the investment.
Okay, thank you very much. Next question. Many of the real cases you showed us were having a real short payback time. What was the energy price used? Was it the current, or is it the current one or the one before the crisis?
Yes, good question. Normally, the cost energy is given by customer with the average price of the current year. For example, in the first example is the 2 fuel storage tanks. Was before the crisis with a cost of energy around 60 euros per megawatt hour. In the second case, in the petrochemical company, it was after. During the crisis, the cost energy is higher than the first one. It's more or less 150 euros per megawatt hour. We can calculate again or update the report with the current energy cost if the client wants to do it. Possible to update it, the calculation.
But let me add something on top of what you said, Juanjo, and it's that, if we would calculate with the current prices of energy, of course, the payback time will be much shorter than the ones sold by Juanjo. So even the current scenario is much better than the one used by Juanjo in his slides.
Different, right? If you wait to increase the energy price, you are losing money. Investment could be greater, and you have losing the opportunity to save energy.
Yeah, definitely. Very clear. What is the lead time to implement these projects? I guess it's about the TIPCHEC projects, yeah.
In the two cases we have so more or less 1 year, 1.5 years. The client normally thought that it's necessary to do it or not. They have to talk with the financial department on different parts of the companies, and when they presented this data to the financial department or to the director, they do the investment because the data are very real and you can save money quickly.
In my experience, if I would have to answer to this question, it depends on the company, but at least almost 2 years, and I will explain why. Because usually, you need to if you are working in a big company like ours, for example, you need to wait until next year for having the budget in order to carry out the work that you have to do. So you have the first delay is 1 year, and after this 1 year, you need to wait because usually, when you are managing a process, you cannot stop the process whenever you want just for replacing things. So usually you need to wait until you have a maintenance stop or a big stop for carrying out exactly the insulation work. So at the end, it's quite easy that since the TIPCHEC is done until the solution is completely in place, 1 year and a half is, I would say that it could be quite an average.
Okay. Yeah. Okay, next question. If we want to invest in marketing, what points do you think we should educate more about this topic to our target customers?
Wow.
A lot.
That's quite a complicated question. I mean, invest in marketing. Well, actually, you have our own example. Actually, I'm working, even that you have seen that the presentation itself was quite technical, but I'm working for marketing. I'm working in marketing department. So one of the investment that we have done, for example, in the Saint-Gobain group, is increasing the knowledge of our people and increasing the dedicated people to this task of explaining how many good things the insulation could bring. So this is the biggest investment that we have done, investing in people dedicated to this topic. I think that is the best investment that you could do in terms of marketing. I mean, because I don't know if this is exactly what you had in mind when you raised the question, but if you are thinking of brochures or information in the internet or this stuff, for sure that it would help. But I think that, you know, having the right people and the right teams dedicated to run calculations to explain how it works is the best marketing investment that you could do. Again, this is an answer from my point of view. Maybe, you know, from, I don't know exactly who is raising the question. If it would be someone working in production, probably the answer would be different.
Okay, very clear. Then coming back to the previous question, the person who asked it has put some precision on the question. The question about the lead time. Since the validation of the project and the CapEx, what is the lead time to do the audit and then to insulate?
Again, I would be,
audit, yes.
I would be back to my previous answer. I mean, imagine that we have executed completely the deep check audit, and we have hand over to you the report, and now the report is in your hands. It will be up to the probably financial department first, just to say, okay, you can go with this investment, and later on there will be a second step with the technical staff, just to see how and how and when it can be done in our real plant. So at the end, the lead time, exactly the lead time from the tip check to the installation, the final installation of the product, is depending on, first, financial, when they are going to give us the okay, and probably the okay will be for next year, not for the current year, when the study has been done. And later on, with the technical team, you should to determine exactly when you are going to carry out the works on your line. And probably it will take some months, because I guess that your process is not stopped every day. So at some point, the way that we are doing in our plants is usually we have a summer stop, so a big stop, a big maintenance stop, and precisely at this time is when we carry out all these kind of projects and works.
Okay, thank you, Alberto. I think we can take one last question. We are almost out of time. So you show the annual CO2 reduction. What is the CO2 impact of the insulation material itself, coming from its production, transport, installation, and end of life? After how many years is environmental break-even typically reached?
Oh, I don't have really an answer. I don't know exactly. I couldn't give you an answer. I would need to study. I never studied that in that sense. So maybe you can give us your contact. We can contact you and give to you this information back. Actually, I don't have it in mind. Sorry for that.
Alberto, what we are often saying is that our insulation materials make savings that are equivalent, or 300 times equivalent to the CO2 emissions they generate, right? Isn't this something?
Yes. Yes, you could take that figure if you want. Yes.
I think so, yeah. Okay. So I think we need to conclude now. We have some more questions, and I propose we can maybe treat them by email later on. So it's time. For more information, you can also reach out to us via our website or our LinkedIn page. And I would like to thank once again both of you, Juanjo and Alberto, for your expert insight. Very interesting. And I would like to thank all the participants also for your listening and active participation and raising questions. And we hope to see you again at one of our webinars in the future. Thank you and goodbye.
Thank you very much, everybody.
Thank you very much.